Okay, so this is the last question. This one was, I think, the hardest question as a whole. Part of it is because there's a lot of thinking that you have to do before you even come up with a solution strategy. They give you a lot of information. Typically in MathHL, usually the information that they give you usually is captured by the diagram. So if you feel like you don't fully understand the description, usually you can go to the diagram. But in this case, the description actually matters a lot. This is one of those rare cases where it does. So they say a diagram shows the plan of an art gallery A meters wide. So this is the width. This is the gallery, I suppose. Line segment AB represents a doorway, so this is dotted line is a doorway, leading to an exit corridor B meters wide. Okay, so you have an exit corridor here, and it's B meters wide. In order to remove a painting from the art gallery workers measure CD, so they measure CD for various values. So they say CD is denoted by L for various values of alpha as represented in the diagram. This is alpha. Now this is key. They're saying that they have a painting that they need to take out from the art gallery, and they're going to do that. The workers are going to do that by measuring CD for various values of alpha. So alpha is a variable. I think it's very important at this stage to kind of jot down what the variables are. So the variables are, number one, alpha is a variable. So what I'm saying here is they're going to kind of, so that's one value for alpha, but they might measure like this, and they might measure like this. They're measuring lengths at different alpha values, okay? And the length CD is also variable, okay? So CD, the length CD, or L, they call it L, CD and L are variable. So as alpha changes, CD is also changing. And you need to kind of have that mental picture going into the question. And that's where, at this stage, I would probably stop and think through what the variables are, think through what's the independent and dependent variable, and really understand the problem before you even start doing the question. Okay, so once we have that mental picture in our minds, we're going to go ahead and we're going to try part A. Part A says if alpha is the angle between CD and the wall, show that L, which is CD, is equal to A divided by sine alpha plus B divided by cosine alpha. Alpha ranges between 0 and pi over 2. Okay, so first thing I'll do is maybe drop a perpendicular down here. Just call that, what do we want to call that? Maybe E. Okay, so we can see in triangle ACE, we can see that the sine of alpha is equal to CE divided by AC. Okay, and so that means that AC is CE divided by sine alpha. Okay, we can also see, so that's me using this triangle. The reason I'm using that triangle is because they need some notion of length. The length L here is CD, and CD is the same as AC plus AD. Okay, so now I have an expression for AC. I'm trying to get an expression for AD. Okay, we can see that these two angles are the same because they're opposite angles. So we can use a different triangle. So in triangle ABD, we're going to use, I think this time we'll use cosine. Yeah, we need to use cosine because they also want cosine in the expression. So cosine of alpha is equal to AB divided by AD. So in this case, what we're going to do is we're going to isolate for AD. AD is equal to AB divided by cosine of alpha. Okay. Now we have an expression for AC, and we also have an expression for AD. So what we could do is we can just add those two together. Because if you take the length AC and you add the length AD, you're going to get the length, do in a different color, you're going to get this length, right? So that's kind of the outline of the proof. Okay, so let's write this all down. I'll label this as 1, label this as 2. So we can say something along the lines of, since L is equal to AC plus AD, therefore L is equal to CE divided by sine alpha plus AB divided by cosine alpha, and that's using 1 and 2. Now CE though, this length CE is the same as A, okay? And this length AB is the same as B. Okay, so then we could say this is equal to A plus divided by sine alpha plus B divided by cosine alpha. And you can say like that's because A is CE and B is AB, but I think that's clear. Okay, so that's it. That's part A. Let's move on to part B. Okay, so part B is saying if A is equal to 5 and B is equal to 1, find the maximum length of the painting that can be removed through this doorway. Okay, so this is the formula that they give us from earlier. I'm going to take that formula and kind of these values A and B here are just constant values. Okay, so that's important. Here, maybe I'll jot this down. L here, the length that the workers measure is a function of alpha. Okay, because you're varying alpha. So, and as you vary alpha, L changes. So L here is a function of alpha. A and B here are just constants. Okay, so don't get confused here. A and B are just constants. They just kind of represent like the width of the art gallery or like the width of the corridor or whatever, but those widths are constant. You're not varying those. All you're varying is the angle, and then the length changes as you vary the angle. Okay, so when A is equal to 5 and B is equal to 1, we have the following. The length, which is a function of alpha, is equal to 5 divided by sine alpha plus 1 divided by cosine alpha. Now at this stage, what you want to do is either do one of two things. If you want to find, or here they want you to maximize length, okay? Or actually, we'll go over this, but actually they want the maximum length of the painting. So you definitely want to optimize the length, okay, in some form. One way to do that is to do the derivative. Another way to do that, because you have a calculator, is to just use a calculator. That's what I'm going to do. So I'm going to say, using GDC, here's the graph of the function. Okay, so here's the graph. This is y equals to L. Maybe instead of y, actually, I should write L and alpha. Okay, so here's the graph. The graph looks like this. You can use the analyze graph find minimum feature to find the coordinates of the minimum. The coordinates are 1.04, comma 7.77. Okay. Now at this stage, you could find the exact values, but honestly, if the question doesn't say find an exact value, you could just use the GDC to find the approximate value, and that's fine. So from this graph, hopefully you guys noticed something strange. When I first did this question, I was like, what's happening? Because the question says find the maximum length of a painting that can be removed. And here you're not getting a maximum. What you're getting here is a minimum. So it's kind of strange. It's strange that you're getting a minimum and they're asking you to find a maximum. And the reason that that's the case is because actually the minimum here that you get for L corresponds to the maximum painting that you can kind of get through the art gallery. So here, if we go back to our drawing initially, you see how here I changed the angles alpha here. And as you vary alpha, the length L changes. Now, if you're trying to get a painting through the corridor, like here's the painting, okay? So here's the painting you're trying to get through. The maximum length of the painting that you're going to be able to get through is going to correspond to the minimum value for L, right? So whatever the minimum value for L is here, whatever the minimum that we measure, that's going to actually be the maximum length of a painting that you can get through the art gallery. That's kind of very confusing, and that's what makes this question very tricky. But this painting is going to be of some fixed, length. And the max painting length that you can get through is going to correspond to the min value for L. Okay? Okay, so we go back, and you would get a reasoning mark for this. Okay? Therefore, the min of L corresponds to max painting length. Okay? And you would get a reasoning R1 mark for that. That's kind of tricky. Therefore, you can say the max painting is, or maybe we can say max painting length is 7.77, and then don't forget that you want units. So if we go back to the question, what does the question say? It gives you units for like B, which is the corridor, and the art gallery. So these are both in meters, and so your answer is going to be in meters. Okay, and that's part B. Okay, so here's part C. Part C says let A be equal to 3k, k is a constant, B equals to k is a constant, because A and B are also constants. Find dl by d alpha. So they want you to find the first derivative of the length with respect to alpha. And this is the formula for L that we found in part A. Okay, so what we need to do is just set A and B to their particular values here. So you can say when A is equal to 3k and B is equal to k, we have L is equal to 3k divided by sine alpha plus k divided by cosine alpha. Okay. Now, remember, k is a constant, okay, because here you're dealing with L as a function of alpha. Alpha is varying. So if we take the derivative, actually, before we take the derivative, it might be easier to write this like this. Okay. When we take the derivative, what you can do here is treat this like a constant. Okay, so one of your rules for derivatives, and a lot of you are forgetting this one, it's a really handy one. If you have derivative with respect to x of a constant times a function, that's the same as the constant times derivative of the function. Okay, so if you have a constant in front, just ignore it. Just take the derivative of this thing. Okay, so you can leave the constant in front. Okay, bring down the exponent. Here the outside function is a power function, so bring down the exponent. Leave the inside alone, subtract 1 from the exponent, and then multiply by the derivative of the inside. That's going to be cosine alpha. Okay, and then same thing, leave the constant, bring the exponent down, leave the inside, subtract 1 from the exponent, multiply by the derivative of the inside here. Okay, so that is your derivative. It looks kind of ugly, so let's just simplify a little bit. So here I'm going to write this as a positive exponent. This is going to be negative 1 times 3k times cosine alpha. So that's going to be negative 3k cosine alpha divided by sine squared alpha. And then here we're going to have a negative negative. That's going to make a positive. We're going to have k times sine alpha divided by cosine squared alpha. Okay, and that's it. That's all the question asks us to do because it just wants the derivative.